So welcome to Sotantra education. In this lecture we are going to discuss about the concepts of array. Now suppose we want to write a program that reads 5 numbers, compute the average and find out how many numbers are above the average. So I am writing the same thing here. So the program is going to read, consider 5 numbers, then compute the average of the 5 numbers and find out how many numbers are above the average. So you want to write a program for this, that is read 5 numbers, compute the average and find how many numbers are above the average. So this program we can divide into two parts. One is, so the first part is read 5 numbers and read 5 numbers and find average, and in second part we can write find or compares each number with the average and find how many numbers are above the average. So here we can write in second part, compare each number with the average and find it is above the average or not, and find how many numbers are above the average. So simple one. So first we write the program that is going to take input from the user, then find the average. In the second part we will compare each number with the average and find how many numbers are above the average. So you can see the complete program here. So it is like this: import java.util.scanner to take input from the user, then class test, the class name, and inside class we have written the main method, publish static void main string args, then scanner ip equal to new scanner system.in to take input from the user. Then we are writing the statement, enter 5 numbers, and the user is going to enter 5 numbers after this, and the first number is stored at n0, second number is n1, third number at n2, n3, n4, like this. Then we are computing the average using the statement double average equal to n0 plus n1 plus n2 plus n3 plus n4 divided by 5.0. So here we are writing 5.0 because the average value is of double. So if we write 5, then we are going to get the integer value. That's why we are writing 5.0 to get the average in double. Okay, so you can, in your program you can check the difference by writing here 5 and 5.0. Now we can print the average is average. So here it is going to print the value of average that is computed here. Now in the second part, so this part, in this part we are going to find how many numbers are above the average. That means we are comparing each number with average. So if n0 is greater than average, we are incrementing the value of count. So initially we have taken count equal to 0. Then compare n1 with count. If n1 greater than average, increment the count. Similarly compare n2 n3 and n4, and at the end print the number of values above the average is count. So here you can see the complete program. So it is of two parts. The first part is taking the input from the user and computing the average, and the second one is comparing each number with the average. So here you can observe we need to use 5 different variables to store the number. So here we are using 5 different variables to store the number, and these variables are n0, n1, n2, n3, n4. So 5 different variables we need to store 5 different values, and repeatedly write identical code 5 times. So here you can see if n0 greater than average, count plus plus, if n1 greater than average, count plus plus, if n2 greater than average, count plus plus, if n3 greater than average, count plus plus, if n4 greater than average, count plus plus. So we are repeatedly writing the identical code 5 times to compare each number. So consider the situation when we need 100 numbers for the average computation. So instead of 5 numbers here, we need 100 numbers, and we want to find out how many numbers are above the average. So in this situation, it is required to manage 100 variables. So in this situation, it is required to manage 100 variables. Like we can take the variables n0, n1, n2, n3 like this, n99. Then again we need to write the code, identical code 100 times, like if n0 greater than average, count plus plus. Similarly we write if n1 greater than average, then count plus plus. So in this way we write up to n99. So if n99 greater than average, then count plus plus. So here we need to write the identical code 100 times. So in this situation, we need to manage 100 different variables. So consider another scenario where we want to find how many students have secured above the average mark in an exam, and assume the class has 500 students. So assume one class has 500 students, and we want to find how many students have secured, or number of students who have secured above the average mark. So in this scenario, it is required to manage 500 different variables for this, because we need to store the mark of 500 students, then we need to compute the average, then compare each mark with the average. So it is required to manage 500 different variables if we follow this approach. So writing a program in this way would be impractical, because it is very difficult to manage large number of variables. So for this, Java and most other high level languages provide a data structure that is array to deal with such type of scenarios, or we can say the array can deal with such type of scenarios in an efficient way. Then what is array? So array is a collection of variables of the same type. So we can write like this: an array is a collection of variables of the same type. So here same type is very important, so please note that. So array is a collection of variables of the same type. So you can make an array of ints, doubles, or any other type, but all the values in an array must have the same type. Instead of declaring individual variables such as n0, n1, n2, n3 like n99, so we can declare an array variable such as or numbers or number and use numbers 0 inside square bracket, write 0. Similarly numbers 1, numbers 2, like this. We can write numbers 99 to represent individual variables. So here numbers is one array variable and this number 0, number 1, number 2, like this. Number 99 represents individual variables or individual marks of students, like that you can consider. Now here you can observe this one. So here in this example the name of the array is C. So we are considering numbers, so here the name of the array is C. Now C of 0, C of 1, C of 2, C of 3, C of 4, 5, like this. C of 11 are the individual numbers. And what is the value of C of 0 is 45. C of 1 is 6, C of 2 is 0, C of 3 is 72, C of 4 is 1543, like this you can consider C of 11. And these values 11, 10, 9, 0, 1, 2. So these values written inside square brackets are called as the index, or we can write this one. So here it is written, you can observe index or subscript of the element in array C. So here name of the array is C and these numbers are the index. So this figure shows a logical representation of an integer array called C, and this array contains how many elements? So this array contains 12 elements total. So in this array you can find 12 elements and the index is from 0 to 11. So please note that in array the index always starts from 0 and the elements of the array C are C0, C1, C2, C3, like this, C11. So now we will discuss how to declare array variables, create arrays and process arrays using index. So to create an array you have to declare a variable with an array type and then create the array itself. So array types look like other Java types except they are followed by square brackets, like this. So array types is similar to other type declaration, but they are followed with this square bracket. So for example, we can write int the square bracket counts. So this int square bracket counts, it declares that counts is an integer array. Similarly, you can take another one, double square bracket values. So it declares that double square bracket values, it declares that values is an array of type double. Similarly, you can take any other data types, like you can write character array, then AR1, like this. You can take some other examples. Now again consider the same example. Suppose we write int counts. Then here this statement declare that counts is an integer array. So please note that here the array is not created. This one int square bracket counts, then here array is not created. Only the reference variable counts is created. That means here the memory is assigned to the variable counts, that is going to refer one integer array, or we can say the variable counts is going to point one integer array, or we can say the variable counts is going to store the address of one integer array, and the actual array is not created here following this statement. So how to create the actual array? So for that we need to use the new operator. So using the new operator we can write like this: counts equal to new int, suppose 5. So 5 is the size of the array here. Here this 5 means the size of the array. So when we execute this statement counts equal to new int 5, one integer array of size 5 is created and its reference is assigned to counts. So here this statement creates one array variable counts, and this statement creates actually one integer array and the reference is assigned to counts. Okay. So now we will write another example. Suppose double values. So like we have discussed, here values is a reference variable that is going to refer one array of type double, and here after executing this statement double values, the array is not created. So to create the array we need to write this one, new double, suppose size we are giving 10, any size you can give, and after the array is created we need to assign its reference to a array reference variable or to a array variable. So for that we can write values equal to new double 10. That means when we execute this statement, one array of type double having size 10 is created and its reference is assigned to the array variable values, and here this statement creates one reference variable values. Or we can combine these two statements. So here the array reference variable is declared and here the array is created. So we can combine these two statements and write a single one like this. We can write double values equal to new double 10. So we can combine these two statements and write it in a single one. So this statement is equivalent to the two combination of these two. Similarly, here we can combine these two statements, this one and this one, and write. So here you can write int counts equal to new int 5. So this int counts equal to new int 5 is equivalent to these two statements. Okay. So now consider this one. If we declare int a, then 32 bits of memory is allocated to a. We know this previously we have discussed, because the size of the integer variable is 32 bits. So if we declare int a, then in memory 32 bits of space is allocated to a, and a can store any integer value. So here the size of the box is, you can consider size is equal to 32 bits, and here we can store any integer value like 5, 10, 15, anything we can store. Similarly, if we declare double b, then in memory 64 bits of space is assigned to b, and we can store any real number here in the box, suppose 5.91, like this. Okay. Now why if we write int array counts, why the memory or why the array is not created? So if we write int a, the variable a is created and memory is assigned. So if we write int array counts or int square bracket counts, why the array is not created? So here the array is not created, but the reference variable is created, because array is not a primitive type or primitive data type. Array is not a primitive type, it is of reference type. So array is not a primitive data type, but double, int, short, byte, char, boolean, long, float. So these are primitive data types. So when we declare one variable of primitive types, then the memory is assigned for that variable, and we can store the value of that type. And declaration of an array variable does not allocate any space in memory for the array, because array is not a primitive type, it is of, or it is a reference type. So the declaration of an array variable creates a storage location for the reference to an array. So if we declare int square bracket counts, then in memory the storage location for this reference variable counts is created. So this storage location for counts is created. And what is the size of this counts? So the size of this counts variable is 32 bits in 32-bit memory, 32-bit system, and it is 64 bits in 64-bit systems. If we write counts equal to new int 5, so this statement counts equal to new int 5 creates an array, integer array of size 5 and returns the reference to counts or assigns the reference to counts. So when this statement gets executed, the array is created and the memory is assigned for the array. But when we write this one int square bracket counts, the array variable is created and actual array is not created. So here the actual array is created. So you should think that the array and the variable that refers to it as two different things. So pictorially we can see like this. So here one integer array is there and its size is 5. 1, 2, 3, 4, 5, and the first one is okay. So here you can think that counts is a reference variable that is going to refer the integer array. Now this one is counts of 0, the second element is counts of 1, the third element is counts of 2, the fourth element is counts of 3, and this one is counts of 4. So counts of 0, counts of 1, counts of 2, counts of 3, counts of 4 are the individual elements, and you can assign some values like 5, 25, 7, 13, like 15, like this. So count of 2 is 7, count of 3 is 13, like this. Okay. Now consider this statement int ar equal to new int 5. So this statement declares an array variable ar and creates an array of 5 elements of int type and assigns its reference to ar. We have already discussed what does this statement mean. Now to initialize the array we can write the code like this. So here array is created. To initialize this array we can write ar0 equal to 7, then ar of 1 equal to assume 23, then ar of 2 equal to assume 15, then ar of 3 equal to assume 55, ar of 4 equal to suppose 13. Now pictorially you can see this one, that we have one integer array of size 5 and AR is referring to this array, and this first one is AR of 0, the second one is AR of 1, this one is AR of 2, the next one is AR of 3, next one is AR of 4. So what is the value of first element? Or AR of 0 is 7, AR of 1 is 23, 15, 55, then 13. So pictorially you can see this one. So this is the array. So you can see the figure. So here this AR is a variable that contains a reference to an array of 5 int elements, or you can say AR stores the address of this array. So we will see one more example, like how to declare an array, how to create the array, and how to initialize the array. Suppose consider the example like this. Double array, suppose BR equal to new double, suppose 6. So here this statement creates one array of type double that is of size 6 and assigns the address of the array to BR. Then if we execute this statement, then 6 into 64, that is equal to 384 bits of memory is allocated to the array. So here please remember that when the space for an array is allocated, the array size must be given. So here array size is 6. So the array size must be given when the array is created, or when we allocate the space for an array, or when we allocate the space in memory for the array size must be given. So the array size specifies the number of elements that can be stored in the array. So here it is given 6, and the size of the array cannot be changed after the array is created. So the size of the array is fixed. So I am writing the same thing here. The size of one array cannot be changed after the array is created. So once you create the array by giving some size, you cannot change the size of that array. So here in this example, the size of this array is 6, or we can say the size of the array BR is 6. So we cannot change its size. So it is fixed. Okay. Now every array knows its length. So we can get the size of the array or length of the array using array reference variable dot length. So here what is the array reference variable in this example? It is BR. So if we write BR dot length, so it is going to return 6. Similarly, in this example, if we write AR dot length, so it is going to return 5 because here the size is 5, you can see. So for every array we can get the size or we can get the length of the array by the syntax array reference variable dot length. Okay. So now we will discuss another example, that how to declare, how to create and initialize the array. So here this one we are discussing. So you can write double the square bracket, double square bracket br equal to new double, suppose 6. So after executing this statement, the array is created. So here consider this is the array and it has 6, the size is 6. So 1 2 3 4 5 6 and br is going to refer this array. Now this element is br of 0, the 0th element, or we can say this one is br of 0. Similarly this is br of 1, br of 2, br of 3, br of 4, br of 5. So always the index starts from 0 and the maximum index is size minus 1. So here size is 6, so maximum index is 6 minus 1, that is 5. So if one array has or if you consider the array is of size n, then the maximum index is n minus 1 and the minimum or the starting index is 0 always. Okay. Now we want to initialize this array. So initialize, how to initialize? So you can write br of 0 equal to 5.3. So because this array is of type double, you can put real numbers. Then br of 1 equal to 7.5. Then br of 2 we can write 3.4. Then br of 3 we can write 5, because if we write 5 then it is stored as 5.0. Similarly br of 4 we can write 11.9. then br of 5 we can write suppose 7.31, like this. So here it is 5.3, 7.5, 3.4, 5.0, 11.9, then 7.31, like this. Okay. So we have already discussed how to declare an array, create an array and initialize the array. So here in one statement we are declaring and creating the array, and using this we are initializing the array. Now you can declare, create and initialize an array in one statement using the concept of array initializer. So how to use array initializer? So for example, consider this statement double square bracket my AR equal to 1.9, then 2.3, 5.2, then 3.5. So if we write these numbers inside a curly braces, then this statement double square bracket my AR 1.9, 2.3, 5.2, 3.5. So this statement declares, creates and initialize the array my AR with 4 elements, and the elements in my AR are 1.9, 2.3, 5.2 and 3.5. This line double my AR equal to 1.9, 2.3, 5.2, 3.5. This statement is equivalent to this one I am writing now. So, if we write double my AR equal to new double then 4, then my AR of 0 equal to 1.9, then my AR of 1 is 2.3, my AR of 2 is 5.2, my AR of 3 is 3.5. So, here we are initializing the array my AR, and here we are creating the array and assigning the reference to my AR. So, these statements, so let me select a different color. So, these statements is equivalent to this one. So, here in one line we can declare, create and initialize the array, and this is called as, this concept is called as array initializer. If we declare, create and initialize the array in one line, this concept is called as array initializer. And here you can observe that if we use the concept of array initializer, the new operator is not required. Here we are not using the new operator, but here we are using new operator because here it is not using the concept of array initializer. So, using the concepts that we have discussed till now, we will write some simple programs on array and see how the array works. So, the first program is like this: read some elements from the user and store that in the array or in a array and display these elements. So, for that we need to first create an array. So, like this we can write int AR equal to new int, assume the size is 3. So, for simplicity we are considering the size 3, you can take any value as size. Now, you can ask the user to enter 5 numbers. So, we can write system.out.println, enter. So, 3 numbers. So, here the size is 3. So, enter 3 numbers. Then we will receive the numbers like this: AR of 0 equal to IP dot next int. Then what is IP? So, IP is a scanner class object, like we need to write here scanner IP equal to new scanner system.in. Okay. Similarly, we can write AR of 1 equal to IP dot next int, then AR of 2 equal to IP dot next int. So, instead of writing these 3 lines, AR of 0 equal to IP dot next int, AR of 1 equal to IP dot next int, AR2 equal to IP dot next int. So, you can use a loop, and inside this loop we can write this one. So, just I am writing the loop here. in a different color I am writing. So for int I equal to 0, I less than ar dot length, because we have discussed that every array knows its length and we can find the length of the array using the reference variable dot length. Then I plus plus, we can write ar of I equal to ip dot next int. So previously we are writing ar of 0, ar of 1, ar of 2 like this. So this is impractical. If the array has 10 elements or 15 elements, so we need to write this one. So instead of this we can write a loop. Then for displaying the array elements we can also write a loop. So we can write for int I equal to 0, I less than ar dot length, I plus plus, then system dot out dot print ar of I plus some space. So this one is for taking input and this one is for displaying the array elements, and here we are creating the array of size 3. So you can see the complete program here we have written. So import java.util.scanner to take input from the user. Then class test, inside class test we have written the main method. Then scanner IP equal to new scanner system.in, then int square bracket ar equal to new int 5. So here we are taking the size of the array is 5. Now we are writing system.out.println enter 5 numbers. So it is going to display enter 5 numbers on the screen. Then we are using a for loop to receive the inputs from the user. So for int I equal to 0, I less than ar dot length, I plus plus, ar of I equal to ip dot next int. So these two lines are for receiving the inputs from the user and store these inputs in the array ar. Now the next line system.out.println the array elements are, it is going to display the array elements are on the screen when this statement gets executed. Now using another for loop, this one we are displaying the elements in the screen or on the screen. So this is a simple program that uses the array to store some elements and display the elements. Now if we want to print or display the elements in the reverse order, that means first if we consider this one, so in this example first we need to print ar of 2. So first print system.out.print ar of 2, then system.out.print ar of 1, then system.out.print ar of 0. So if we want to display the elements in reverse order, so this should be the order for displaying the elements of the array in reverse order. So here we are starting from 2. So what is 2 in terms of array length? So this 2 is equal to ar dot length minus 1. So this is the highest index. So the highest index is size of the array minus 1 or length of the array minus 1. So we need to first display the element that is indexed at size minus 1 or length minus 1. That's why we are writing this. We can write this 2 in terms of ar dot length minus 1, and first we display ar of 2, then ar of 1, then ar of 0 like this. So when we get 0 we can terminate the loop. So you can, if we want to write this inside a loop, we can write like this: for int I equal to ar dot length minus 1, then I greater than equal to 0, I minus minus. So I value is going to be decremented, and inside the loop we can write system.out.print ar of I, simple. So it is going to display the element at ar of I. So this one. So you can see the complete program here. So up to this it was same as the previous program up to this. So enter 5 numbers. So we are using a loop to receive 5 numbers from the user and store that in the array. So up to this it was same as the previous example. Now after this we want to print the elements in reverse order. So here we are writing the array elements in reverse order are like this using system.out.println, because after execution of this statement this one is going to be displayed on the screen. Now after this we are writing for int I equal to ar dot length minus 1, I greater than equal to 0, I minus minus, system.out.print ar of I, then plus some space is there like we have discussed just now. So this program is going to print the elements of the array in reverse order, and here you can observe this one is for, this line is for creating the array, and these lines for taking input, and these lines, these 3 lines for displaying the array elements in reverse order. So it is a simple program. So we will discuss some more programs using the concepts of array in the next lecture.